As a recreational diver, you always make no-stop dives. This means that at any time during a dive, you could ascend directly to the surface if you had to. To do this, you stay within your computer's no-stop limits, which you can access before the dive for planning. The deeper you dive, the faster you absorb nitrogen. So as you can see, the no-stop limits get significantly shorter as depth increases. Times differ slightly with different models, but these are typical. During the dive, your computer updates your no-stop time based on the time you spend at each depth. Your remaining time will be shortest at your deepest point, but it increases as you ascend because nitrogen absorption slows. Diving so you get more time by ascending to a shallower depth is called multi-level diving. This is one of the big advantages of dive computers. Tables base your time limit on your deepest depth, even if you don't stay that deep the whole dive, which is often not the case. Note that the exception to this is the ERDP-ML, which lets you plan multi-level dives. Let's look at how your limits might change during a typical dive. These divers want to dive to 18 meters or 60 feet. Explore a bit, then gradually work their way upward so they stay well within no-stop limits and have 50 bar or 500 psi air left when they surface. During pre-dive planning, they scroll their no-stop times. Their computers show 140 minutes no-stop time at 12 meters or 40 feet, and 55 minutes at 18 meters or 60 feet. They decide they will descend to 18 meters or 60 feet, then start back up at 30 minutes. The dive goes as planned. After half an hour at 18 meters or 60 feet, their computers show 25 minutes no-stop time remaining. They head upward along the reef and level off at 12 meters or 40 feet. Their computers show 83 minutes no-stop time. This is a lot more time than they had at 18 meters or 60 feet, but their bodies have absorbed nitrogen, so it's less than the 140 minutes they had before diving. However, it's more no-stop time than they have air, so they end the dive with enough air to ascend, make a safety stop, and surface with a 50 bar or 500 psi reserve. Dive computers and tables' ascent rates are part of their calculations, so stay within these rates. Safety stops are not required for surfacing within model limits, but you make them for added conservatism well within limits. In an emergency, like an out-of-air situation, you would omit the stop, but otherwise make it. If you accidentally exceed a no-stop limit, on the other hand, you must make a decompression stop. In this case, you need the stop to release excess nitrogen before surfacing. Without the stop, you would exceed model limits and have an unacceptable decompression sickness risk. You'll learn more about emergency decompression stops in Section 5. After a dive, your no-stop times are shorter than before the dive. This is because your body still has excess nitrogen from the previous dive. We call the nitrogen from a previous dive residual nitrogen, and a dive made while you still have residual nitrogen a repetitive dive. When you make a repetitive dive, your no-stop limits are shorter because you already have nitrogen in your body. Your computer must account for this residual nitrogen as well as what dissolves into your body on the repetitive dive. You have to wait several hours without diving, usually 12 or more, before body nitrogen levels return to normal. After that, a dive isn't considered a repetitive dive. Although you still have nitrogen in your body after a dive, during a surface interval between dives, the nitrogen levels decline. As a result, the longer the surface interval, the more no-stop time you have on a repetitive dive. Your computer calculates your theoretical nitrogen levels continuously, so it is important that you use the same computer for all dives throughout the day. It remembers your residual nitrogen, so don't share or trade computers, and don't turn it off. Most models won't let you anyway. If you don't dive with the same computer continuously, it can't accurately calculate theoretical nitrogen. Diving without using the same computer for all dives greatly increases your risk of decompression sickness. And follow any additional manufacturer recommendations regarding the use of a computer for repetitive diving. Before using your dive computer, read the manufacturer literature completely. Dive computers vary in their features and layout, but as a minimum, virtually all tell you your no-stop limits before a dive. While underwater, you can read your depth, elapsed time, and your no-stop time remaining. An ascent rate indicator guides your ascent speed, and emergency decompression information comes up if you accidentally exceed a no-stop limit. Between dives, you can read your surface interval time and recall previous dive information. When you're ready to plan your dive, you activate it by pressing a button or touching contacts like this. With your buddy, agree on a maximum depth and time based on the scrolled no-stop limits. Remember that repetitive dives have shorter no-stop limits, and that shallower dives and multi-level dives have longer ones. Plan a maximum time and your air use limits. You often have far more no-stop time than your air will last. You turn the dive based on whichever limit you or your buddy reaches first: time, air supply turn point, or remaining no-stop time. You may want to note these on a slate to reference during the dive. There are 6 guidelines to follow while diving with your computer. 1. Dive the plan. Don't go deeper or stay longer than planned just because your computer will let you. 2. Stay well within computer limits. Never let your remaining no-stop time get close to 0. 3. Follow the most conservative computer, yours or your buddy's. 4. Watch your SPG and manage your air supply. 5. When you can, start at the deepest point and progress shallower. When making more than one dive, make the deepest dive first. This gives the most no-stop time and is considered a conservative diving practice. And 6. Ascend slowly within your computer's ascent rate and make a safety stop. Dive computer failure is very rare. Most self-check and confirm adequate battery power when activated. If one fails during a dive, however, you have 2 options. The first is to ascend, make a safety stop, and end the dive. By diving well within limits, you should be within acceptable theoretical nitrogen limits. If you have 2 computers and have been diving with both of them, your second option is to continue the dive with the working computer. If your computer fails between dives and you've been diving with 2, you can make another dive using the one that works. If you've been diving with one computer and it fails, you may be able to continue diving by using your time and depth information with dive tables, a depth gauge, and timer. Otherwise, you need to wait 12 hours before diving again with a working computer. Divers are not a significant threat to the underwater world, but it's important that we apply environmentally friendly dive techniques. Diver damage is inconsiderate. Other divers want to see the natural beauty and cultural heritage you see. It can also add to the problems where pollution already stresses the environment. More importantly, as a diver, you have a role as the underwater world's ambassador, and how you dive sets an example. Divers see the underwater world firsthand and are often the first witnesses to problems. How you dive is part of your credibility when you explain what you see and add your voice to initiatives that inform the public and protect the underwater world. You can also take direct actions, such as participating in cleanups, removing invasive species, or collecting data for scientists. To learn more about how you can apply your role as a diver to preserving the underwater world, See your PADI resort or dive center and visit projectaware.org.